Hello and welcome to Heat Pump Talks, a special series brought to you by the European Heat Pump Association celebrating its 25th anniversary and Rheem, who is marking their 100th year. In this episode, we'll discover what happens when you install 100 hybrid heat pumps in a Dutch neighborhood, where there is very limited grid capacity. Will it crash the local system, or is there a way to make it work? That's what Rheem wanted to find out. We'll discuss this interesting case study and see what we can learn from the study results. My name is Danae Kokalis and I'll be hosting this episode today. And I'm joined by two heat pump experts, Paul Kenny. Paul Kenny, you're the director of the European Heat Pump Association. You're a former policy advisor for the Irish Climate and Energy Minister, and you're both an engineer and an EU policy expert. You'll be offering the more European, broader perspective to the discussion. And Louis Visser. Louis, you're a research and innovation manager at Intergas, a daughter company of Rheem in the Netherlands. And Rheem is a leading heat pump producer. So today you'll be helping us understand the challenging grid situation in the Netherlands and telling us what we can learn from this. So welcome to you both in this episode.
Thank you. It's great to be here.
First, I would like to start with a light question to introduce the topic. I was wondering if you have a heat pump in your house.
It's a good question. I've just recently moved from Ireland to Belgium, to Brussels. And I had a heat pump in my house in Ireland for 10 years. And when I started looking for a house, while not very common in Brussels, you can find them. And I do have a house with not one, but two heat pumps, one for hot water and one for space heating and cooling.
So it was an important element when looking for a house.
I knew this question would come up on a podcast someday.
Would come in handy. And you, Louis, do you have a heat pump in your current house?
Yes, I do. So when I moved over 10 years ago, my home was heated with gas. And 3 years ago, I upgraded to a hybrid heat pump. So now my gas bill is reduced by 90%, so quite significantly. One could say I could move away from gas completely if I'd like by shutting it off. Yep.
Mm-hmm. So happy with the choice?
For sure. Yes, it was a good investment. Yes, yes.
Okay, great. So in the last episode, we saw that as electrification rises with heat pumps, EVs, and so on, some grids cannot handle peak demand, and that's what creates net congestion, grid congestion. So this can delay new connections or force expensive upgrades. Can you explain how that poses a challenge for the heat pump sector?
Yeah, so in general, as we electrify, our grids have to be upgraded. So as we add demand and as we change our use from when they were originally designed, we have to upgrade them. Different countries have different conditions. So in some countries, you have very large grid capacities, particularly at the local level. Others, you have much smaller grid capacities because they may be dependent more on gas. So each country has to decide how they're going to do that. But in particular, what you have right now is you have the demand for electricity rising more quickly than the grid companies can upgrade the electricity system. Mm. So particularly in the Netherlands, and I'm really interested to hear about the Netherlands, particularly in the Netherlands, they had a very gas-dominated, gas-addicted country almost, you could say, a very gas-dominated distribution system. Homes had predominantly heating with gas and or still have. And as we electrify transport, heat and build out data centers, we really have to tackle this upgrade. But in the meantime, before those upgrades happen, we still have to get the energy transition moving. And that's, I think, the interesting thing about this pilot.
Mm-hmm. So Louis, maybe you can tell us more about this and maybe also about this project that you did with 100 hybrid heat pumps in a grid congested neighborhood in the Netherlands.
Yeah, sure. So over 2.5 years ago, we had this idea that we could see a little bit into the future where we would see this problem arise. So we set up a project. It's actually a government-funded project together with a couple of partners. So, for example, Enexis, which is a grid supplier in the Netherlands, cooperated, but also a data analysis company, Inversible, and enabled me as a project leader. Together, we set up a project, which is, like I said, funded by the government. And in this project, we want to investigate, hey, if we apply hybrid heat pumps at a large scale, what would happen to the local grid in neighborhoods? So we set a number of 100 hybrid heat pumps. We thought that would be a good baseline to investigate. And we looked around the Netherlands for a very typical village neighborhood and see if we could somehow motivate these people to buy an actual heat pump. We found a neighborhood in a small village called Dalen, in which there was a very active community that really wanted to decarbonize the entire village, but they had a lot of, obstacles. This was one of them. So we contacted them and they cooperated in a project and they motivated homeowners to actually procure this heat pump and let it be installed by a regular installer. It's a regular product. And we subsidized a little bit. And this was in the time that gas price was very high 3 years ago. So people were very motivated as well to switch to a heat pump. So that helped. And we supported them also a little bit financially, but they still had to actually want a heat pump. It's not like we forced them. So we found 100 people. Heat pumps were installed 2 years ago. And these heat pumps were all connected to the internet. But we also monitored the local transformer of the electricity grid. So this is like a small concrete building in the neighborhood where this transformer is housed. So we monitored that transformer. And we also monitored all the cables coming from this transformer into the neighborhood. So we had a lot of data coming in, and we analyzed this data for the first winter. And from that, we can draw already a lot of conclusions about what happens in real life, in real homes, in this grid. And this way, we basically set up the project so we could, as a follow-up experiment, by actually turning on and off these heat pumps whenever the grid is congested.
So what did the monitoring from all this data actually show?
Yes, so very typical for a Dutch home is the amount of current one can take up from the grid. So this is a very typical neighborhood, so a single transformer. In this case, it was 400 kVH, so that's 400 kilowatts roundabout. And there were 255 homes connected to this transformer. So very simple math, 400 divided by 255 gives you around 1.5 kilowatts per home simultaneous load. The first thing we discovered, or is basically known, is that you have this duck curve. That's what it's called. So in the morning there's a peak, and in the evening there's a very high peak of usage. So this is very natural, normal. People come home from work, or they start cooking electrically, or they plug in their car. So in the evening between like 3 and 8 is the biggest peak. This is very natural. What we also saw is a huge solar peak in the middle of the day, which is also very typical. And actually this solar peak was larger than the peak of usage. So there was at some point more solar generated than there was ever used in this local grid. And once we've installed these 100 heat pumps, you could very clearly see they added to this load. So you could clearly see these 100 heat pumps turn on and off. And one thing we very specifically looked for is how often do all these heat pumps really run at maximum. So the assumption is always made that heat pumps, for example, can draw 1.5 kilowatts, and you should calculate the grid, basically, that they all run at maximum. But this is not the case. Some heat pumps are on, some are off, some run at an intermediate level. And we saw that the average draw was 800 watts per heat pump, which is much less than people usually assume. So for these 100 hybrid heat pumps, we saw 80 kilowatts maximum load for this transformer. There are many details that we discovered which make it very difficult to optimally control the system. But one thing we saw, these 100 hybrid heat pumps are no issue for the grids at all in this neighborhood.
Okay, so the concerns about the overload were not necessarily justified then, because I understand you had no issue with this project.
Yes, so for these 100 heat pumps, that was fine. But if you would install a hybrid heat pump to all of the 255 homes, the grid would be at capacity in this local level, so maximum. And that basically means it gets very cold. The gas-fired boilers kick in because they help with the heating. they limit the maximum current. But if we would fully electrify this neighborhood with full electric heat pumps, that would be an issue and the grid would need to be upgraded. So it was suitable for hybrids in this case, but for full electric, that would not be possible without some serious reinforcement. Yes.
And when does the flexibility run out for you during the year? Because when the demand goes above this 1.5 kilowatt that you mentioned, when did it run out for you? How did you face that?
Good question. So what we found is we installed these hybrid heat pumps with 100 residents, and they really did not grasp the concept of net congestion. This is the first thing we investigated. We asked them questions, but it was very, very difficult to communicate. So we controlled their heat pumps, but they did not understand what was happening at the grid level or at electricity level. It's very difficult to communicate this, so it has to be a very simple solution where the machine basically takes control and makes sure that it runs efficiently with low cost without causing hassle for the homeowner. So we monitored and controlled these heat pumps, and we experimented with the flexibility, as we call it. So we turned them all on, all off, and we looked at the actual grid loading. But for the homeowners, it was basically a little bit of magic that was happening behind their electricity meter. The second thing we saw is that these hybrid heat pumps on average saved 75% of gas usage for these homes. So there were very different types of homes, some with underfloor heating, some with radiators, some with air heating. But on average, we saw 75%, and the reduction in electricity bill was very significant. So the investment already paid back after like 3 years in this case. So homeowners were very happy with their heat pump. But the grid congestion topic was very, very difficult to communicate. Yes.
And Paul, you have a lot of experience also in heat pump projects. You've been involved in the past. Do you see similarities with what Louise is saying?
Yeah, it's really interesting. Well, first of all, I think homeowners are always happy with their heat pumps. Maybe is something that we might all learn. But yeah, I've been involved in similar studies with the Irish grid companies, and we installed. It was funnily enough 100 as well. Across much more diverse. It was all around the country and maybe a little bit larger buildings in the countryside and so on. So it wasn't around net congestion. It was really around studying the dynamics of what heat pumps do, particularly in cold weather. And I think what's really important to learn from that study and other studies is what flexibility does in terms of allowing you delay those grid upgrade requirements and allowing you understand what actually happens. So time and time again, what we see all over Europe is we think we have a huge problem with heat pumps. We do a big study, and then the solutions are pretty obvious. And it's don't all switch them on together, and don't all switch them on in particular places before the grid upgrades happen, and so on. What's also really interesting about the study is, your average load of 800 watts, that's really quite a small amount of power.
It was a peak, actually.
Yes. Oh, a peak of 800 watts.
Yes.
Okay. Well, I guess it's a particular
type of heat pump.
Particular type of heat pump. Yeah.
Correct.
So when we did that study, and I know in other countries, it does really depend on the heat pump type, the country, the design of the load. So in some countries, you've backup electric heaters that are 3 kilowatts in comparison to 0.8. Whereas in Ireland, we don't need backup heaters because it doesn't get very cold. And the heat pump design standards are relatively easy. And we saw a total load in very peak conditions of 1.7 kilowatts, but that was the house and the heat pump. So you could probably take 400 or 500 watts off that. So we saw with electric driven heat pumps at roughly about 1.3 kilowatts. So what's interesting as well is the design standard or the average load you mentioned there are 1.5 kilowatts, and that varies country by country. So solutions are different. But what is absolutely the solution or the thing that we can really take from this study is the need to think about flexibility and the need to make sure we really actively think about what are the assets we have, what are the types of houses and the types of housing estates we have, and come up with solutions that match that. And where countries where you have a weak electricity grid, a particularly weak one like the Netherlands, and you have data centers and you have a couple of other of those building blocks, it's a solution that really helps in terms of the hybrid, in terms of the flexible heat pump. I think that's probably one of the most important things, but then also the hybridization of it. And that's the bit for me that we all need to learn is if you want to do an energy transition that works for homeowners, that works for the grid, that works for everyone else, you have to intentionally do it. You have to set about a plan. And what's quite interesting is now electricity grid companies, both at the transmission, so the large scale lines, but also at the distribution level, they are now actively planning what does the net zero grid look like by 2040, I think. Generally speaking, we're trying to design our grids to be out of gas for homes by then. We have a target of net zero by 2050, and we know that there are hard to decarbonize sectors like steel and cement and so on, and they have to be the last ones, So I think we really need to see the vast majority of fossil fuels out of buildings by 2040, which is only 15 years away. So we really need to accelerate the investment in grids. We also need to accelerate the investment in flexibility. And one of the interesting things you said there is homeowners shouldn't really be engaged in what their heat pump is doing. And I think that's a really important lesson. Like we as engineers and heat pump nerds, we should be able to solve this problem without really having to engage homeowners in thinking about their heating system. What homeowners want is a warm house that's cheap to heat and doesn't burn the future of the planet. And they're the three drivers across every study we see around what makes people want to take up heat pumps is a good business case, comfortable home, and that level of understanding that you're doing the right thing. So what we see, I guess, in that question around homeowners is what other countries have already taken. I mentioned that the Nordics are flexible first in advance of everyone else, and that's all done seamlessly without homeowners understanding it.
So do you think there's still a lot of work to be done in terms of raising awareness for consumers also?
Yeah, I think across the board, people need to be incentivized, but also I think the narrative needs to be clear. I wonder what it's like. How is that in the Netherlands in terms of the awareness of people in the transition and what they need to do?
I think nowadays everyone in the Netherlands knows what a heat pump is. I think that awareness is there. So that's not really the issue. It's more the complete picture because they're just not sure what the government will do, where the incentives will go in the future. The net congestion now is really an issue. So in the news, you now hear, for example, don't charge your car between 7 and 8. I mean, in the evening or between 3 and 8. So this gives like a doubt in people's minds, like, oh, should I switch to electric or will my power fail? So this is definitely a topic that is top of mind nowadays. So raising doubts about, hey, is it smart for me to decarbonize now or should I wait for something else? So this is very relevant. I'd like to go back to what you said before, the business case and the comfort. That's really what we also saw in this project. So we were a bit skeptical. Okay, we're going to put 100 heat pumps in a small neighborhood. How will people react? They were all happy. Every single one was happy with their heat pump. They didn't really care too much about net congestion. They were okay with us monitoring and doing the experiment for 2 years, but they were just happy, basically. So as long as we solve the technical stuff as engineers, as producers, and we convince people that's a smart choice financially on the long term as well, I think it's like almost a natural process. So I really agree with that. To get a little bit into technical stuff in this project, a lot of people think we should control heat pumps remotely. So the grid operator controls the heat pump of a person, so switches it off. That's something that I think will not be a very good way forward. So people should still have control over their own products in their homes. And we should focus on that because there's still a pretty big movement going towards the remote control. So currently it's not allowed in the Netherlands that people control stuff behind your meter. So the grid operator is not allowed to control your appliances. It's up until the meter. I think we should keep it that way. And it is definitely possible to do it that way as long as people are incentivized to not turn on all their equipment at the same time. So this is something we still need to develop in the Netherlands. What's the ideal case? And I think other European countries are a little bit further than that. So, for example, here in Belgium, right?
Mm-hmm.
Yeah, I think it's really interesting when you see the transition. 10 years ago, it was hard to get something connected to the internet. So I've just moved house and we've had to buy a couple of different appliances. My tumble dryer, my lights, my heating system, my everything seems to be connected now to the internet. And they all have a little QR code and you connect everything and you can program it to go this and that. And, you walk in the door and your lights come on and it's because it's detecting, frequency changes as you come in and out of the house. And the level of complexity that consumer appliances have that engage consumers if they want to be has really risen. And the technology that allows that to happen, particularly in heat pumps, is around many years. I know my flexibly controlled heat pump in Ireland was installed 10 years ago, and it was possible. So this isn't rocket science. It's available in light bulbs. It's available in tumble dryers. It's certainly available in heating systems. But what's the big gap? And the big gap is the incentive. So if you go to book a hotel room and it's in the middle of a weekend with multiple sports things on or concerts and so on, the hotel has scarcity pricing. And that's really relevant for consumers or airline tickets. And it's, that's what we do.
Mm-hmm.
That's not the case in the electricity systems in the likes of the Netherlands and in other countries where we don't have scarcity pricing or abundance pricing.
Mm-hmm.
And unless we get to that level where we say to people, you're really cheap to charge your car in the middle of the night or to run your hot water cycle so that you've pre-charged your hot water tank, or, particularly if you think about the middle of the day in that housing estate, huge abundance of local electricity that's clean.
Mm-hmm.
Why would all those houses not rise up to 21 degrees or 22 degrees, store all that energy in the building, and then over the evening, they don't need it.
Mm-hmm.
And that's the lesson that's really important. And when you see the sort of level of detail that you've gone into this, it's a super project because you actually understand the voltage at a very local level. And when grid companies see all of that, then they'll turn around to the regulators and say, can you please enable this? Because the laws of physics say, if we use all of these cables wisely, it will be much cheaper for everyone. And if we don't, it will be much more expensive and will delay the energy transition.
Mm-hmm. Mm-hmm. So flexibility is crucial in this case to ensure that this successfully evolves in the future. Coming back to the Netherlands, how do you see it on the longer term? How do you see this evolving?
Yes, so it's interesting. So we definitely need to add more cables, more transformers, more reliable, sustainable sources of electricity. So that's one thing. We definitely cannot continue to decarbonize with the current grid. We need more cables, more capacity. But at the other end, we see a large amount of projects starting around smart heat pumps. So there's now a group, it's called an NTA, a Dutch Technical Agreement. That's a literal translation, where all the heat pump suppliers come together and we talk about, hey, how can we, in a uniform way, make our heat pumps controllable so that a home energy manager or a person using simple settings can optimize their heat pump to avoid grid congestion, because it's a very relevant hot topic right now. And also, how can we keep it simple, right? So we don't want people to see this as a bottleneck or as a problem, rather as a solution with which they can make money. So, I mean, like you said, if you turn on your heat pump when the sun shines and you have solar panels, hey, why not use your own energy? That's the best thing there is, right? So this is evolving very, very quickly in the recent year, actually. So when we started the project 2.5 years ago, this was not very relevant at all yet. So it's really, since the energy crisis 2 years ago, the high energy prices, the large adoption of solar panels and heat pumps, we now see the next problem, and we have the solutions, I think. So the results from this project, so in our heat pump, for example, we have software now that can be controlled, that can limit power, that can have a schedule, is already applied in the field in other net congested areas. So we already use results from this project in the actual product.
Okay.
That's the power of software, right? You can just copy paste. Yeah. So yeah.
You mentioned net zero and hitting the climate targets. What do you think we still need to do to ensure that we do reach those objectives?
Yeah, it's a really good question. Across Europe, what we're seeing now is, I don't know, somewhere in the region of 1,000 to 2,000 hours a year of zero price electricity. So last weekend in Brussels, it was quite windy, and across most of Europe, it was quite windy. So we saw very low prices. And these low prices would have told us to charge up our cars, to charge up our hot water, to charge up our heating systems, and provide kind of that buffer between when the wind drops or when the solar kicks in. And when we think about this 2040 transition and so on, we're building out all of this electricity infrastructure for renewables, and then we're curtailing it because we're not building out the flexibility side on the demand. So what we need to do is build out flexible demand. And you know, you mentioned it earlier, the need for batteries. And like what I always consider that every house is a battery. It's, you know, the walls, the fabric, everything in the house, as it warms up, it effectively stores, for want of a better word, heat. It stores heat, yes, but it's essentially electricity being stored. So that's why I think when you think about the smartness and all of these, if we don't deploy smart heat pumps and smart EV charging and smart demand, it's going to make the transition much slower and much more challenging and much less competitive. And we see countries that have deployed it, they will be better, faster, quicker to reach their targets and in a more competitive manner that enables people to have warmer homes for less cost.
Yeah. It will also mean that consumers will need to adapt the way they heat and cool, maybe not in the traditional way of I'm coming back home, I'm cold, I'm turning on my heating, but maybe looking at it from a different perspective.
It's funny that you say that. So we're very active in this field as well as how can you store heat in a building. So not every building is the same, of course. So if you have underfloor heating, you have more ways of storing heat over time. So if you have a big concrete slab, it's easy to store heat. But if you have air heating, you instantly feel this if you turn off the heating, for example. So we have now in our product also adapted a self-learning controller. So it models the heating system itself, and it basically frees the homeowner from thinking about this. So basically the homeowner says, I want to have it comfortable between then and then. And outside of that time, do whatever you want. So store heat or not. So this is up to the heat pump. So we really like the idea of simplicity for the homeowner, where he doesn't have to think about dynamic pricing or storing heat, but the product solves it for them. So this, I think, is the future, and we're working very hard to make this happen. And we're not the only one, right? So I know that. So this is very relevant nowadays, talking about this. Yes.
Yeah.
It was really interesting at the last trade show, when you walk around the trade show and you see all of the different manufacturers, one of the key things they were all saying is we're solving this problem, or we've solved this problem, or our heat pump can do this or that. And I think the interesting thing about that innovation is that's ahead of the electricity regulators and policy in some countries. And I think that's one of the challenges we need to overcome.
And it's also something we hear very often, where we've heard it being said that we will know we have managed and we will have solved the problem when we will not be thinking about our heat pumps anymore. And it will just be something that's, working in the background in our home, and we're not even seeing it or thinking about it. Yeah. Okay. And looking back at this project, what do you think is the main lesson Europe could learn from it?
Right. So there are a couple of lessons we've learned. One is, like I said, the 800 watts simultaneous load, but it's purely for our product. So that we can now use to advise grid operators, hey, you want to install this heat pump, this is a typical maximum load simultaneously. Secondary, if you really want to optimize the grid on a local level, it can get pretty complex pretty quickly. So if you don't mind me saying, so our heat pump is single phase. The grid is 3-phase. We do not know which phase this heat pump is connected to. We do not know which cable to the transformer it's connected to. So if you want to optimize for every transformer and every cable, it will be a very complicated system that's also connected to the internet, has to communicate. You have to have fallbacks. If there's no communication, what do you do? So to make a perfect idealized grid, which a lot of people are attempting to know right now, it is very difficult. And I think we should have a very simple intermediate step where homeowners are incentivized to lower their peaks, to use their own electricity using maybe a small battery or a home energy manager or something very simple. They can just buy and install themselves instead of having to wait for installers. So the second conclusion is keep it simple for the homeowner. Have a very simple case with a good incentive financially that people will adopt themselves. I think that's a very powerful secondary discovery in this project. And the last is, well, like I said before as well, is that once you convince people to buy the heat pump and they have it, they're pretty happy with it. I mean, there are basically no complaints in this project, which was also a surprise to me. That's basically it. Yeah.
And you, Paul, looking from the broader European perspective, what is the main takeaway you think we can learn from this project?
Yeah, it's a really good question. I think it's all about the flexibility. I think when we think about this transition and the need to invest in grids, flexibility means you've got more time to invest in the grid. And I think that's probably one of the key learning that we have. So everyone has to invest in the grids. Every country has it because it's the grid of the future is very different to the grid of the past. And that's consistent across all countries. If you add flexibility, it allows most countries continue to install heat pumps, fully decarbonized heat pumps. And if you don't have the grid capacity, you might need to take that intermediate step. And I think that's the really interesting lesson from this, because, if we take the difference between, I don't know, 800 watts and maybe 1.5 or 1.3 kilowatts or so on, that's in the margin of the design load of most European countries, not necessarily the Netherlands. But if you don't add the flexibility, you're in trouble straight away. And I think that's why we really need to build out that flexibility, that incentive schemes, those either dynamic pricing or at least some form of pricing that incentivizes people to preheat their homes and use that solar power when it's available and use all the wires really intelligently. And it's great to see that sort of level of knowledge and data analysis brought to bear to say, drive this on, get those heat pumps using the available local clean electricity when it's available, because that's effectively what Europe has to do. Lots of clean electricity, and sometimes let's use it.
Indeed. I think that brings us to the end of this episode. We've proven that heat pumps, once again, are a reliable, low-impact solution. Through the data, it's also very clear that heat pumps, when properly controlled, do not overload the local grid. And like you said, Paul, the question is no longer if they can work. It's more about how fast we can deploy them. And I think this project is a great step towards that. To make this large-scale deployment possible, we need the right policy levers and systemic changes in place. In our final episode, we will zoom out one last time to discuss the long-term strategic solutions needed across Europe to future-proof our energy system and pave the way for a rapid and successful transition. Before we go, we want to remind you about Heat Pump Day. This year it takes place on the 21st of October. You can find events, interactive content, initiatives happening across Europe all in one place. So make sure to visit heatpumpday.org. And you don't need to be necessarily a professional in heat pumps. You can also just be a heat pump nerd or an enthusiast, and you can join us in celebrating the clean decarbonization of the heating sector in Europe on the 21st of October. Thank you to my guests, Paul Kenny, Louis Visser.
Thank you very much.
Thank you.
And until next time.